take forward his own career, tell us about his own career, and then go ahead with his talk. Over to you, Sudhanshu.
Thank you, sir. Okay, good morning, everybody, or good evening in India. Today's topic is Geo-Artificial Intelligence and Machine Learning and Internet of Things application in climate smart agriculture. So main goal is to optimize the production. So, and at the same time, we will be taking care of environment. So before starting, let me explain what I'm doing. I am Sudhanshu Panda, as you see my name there. I'm working as a professor at University of North Georgia. It is on the mountains in Georgia, Northeast. I have a PhD from North Dakota State University, which is in the Midwest. Agriculture is the main thing over there in United States. And I did my master's in AIT Bangkok. Most of our agriculture engineering folks from India, that is the middle ground for us to do better research in other places, in India or elsewhere. So I joined not in agriculture engineering. My story is different than most of the smart folks. So I didn't apply for agriculture engineering master's there. I applied for natural resource management. And that became a boon for me that your space technology application research program started at AIT. Being an engineering background, they pushed me to that program. I never had a computer. Even I didn't touch a computer, but everything was by coding. The entire program was by coding at that time. So think about how hard way I learned things. I literally didn't sleep for 3 months. 1 hour, 1.5 hours I sleep. That time computer was just getting new. We have a lab over there. So we just ask each other, learn from students who be there like me. Many students are there in the lab. So we learn just talking to each other, helping each other. That is exactly helping me how to really do great research and how to teach students passionately and make them learn the hard way, not like superficial way. So you will see a lot of things here, and I'll emphasize how with smart knowledge, we can counter any kind of trouble we are facing due to climate change impact, because that is true. Climate change is true, guys. So it's nothing is untrue here. So we need to be ready, and how the advent of AI, advent of machine learning, advent of image processing, space technology, all these things that IoT is part of it. So bring together and just do our best to enhance production. Why enhance production? Because it's a necessity thing. Because population is increasing, resources are decreasing. So you need to find a way to get more production from less spatial areas. And there are always loss for our CAETians. We already know 30-40% production even does not come to your home. And we know agriculture is farm to plate. Like whatever we produce in the field, 60-70% reach to the plate. That 40% just goes away being lost. That can be easily, we can, figure out how to save them. So instantly you got 30-40% production up. Then the next thing is your field is capable of giving you more yield. But we do not do that way. A simple example I'll give. I'm from a village, still I'm a village person. So I do agriculture. I do agriculture here also in United States. I grow like crazy crops. Vegetables, 10 people, family can sustain one single year. That much vegetable I grow and give it to people. So what I meant to say that if we use the resources what we have to produce our things, then we can immediately increase production by another 30-40%. So that would help save some kind of like the trouble we are having, not enough food in some countries or more food some countries that is being lost. Give me one second. It is not moving. Some of the project you don't need to see it, and I'll go quick in many slides. If you need, we can talk about the later. But where it is important, I'll talk because I have a lot much information to share in 30 minutes. So this one actually is explaining how artificial intelligence work, and everything is easy for young kids to work with. So AI encompasses machine learning, neural networks, and deep learning. So, and machine learning is kind of clustering, unsupervised learning, supervised learning, all these things are there. And we'll be talking about how we can implement them in very low-level agricultural stuff. Because as an agriculture engineer, we are in India, we think ourselves one of the lowest rung of engineers. That is wrong thinking. So I need to clear that up. Anybody have that thought, just take that out. Agriculture engineering is one of the best engineering in the world. So we are mix of everything. If you are a civil engineer, I'm doing civil engineering project, like 3 of them, phase 1 to phase 2, phase 3, guys. So, but they know, I explain them how agriculture engineer can do works better than others. So that one we need to, take away from our brain, guys. And this one is showing geo-artificial intelligence. Why geo? Because agriculture is a field thing. It is a geospatial like aspect of engineering. So whatever AI we are using, we need to implement the geo part to it, the spatial part to it. So these are some of the graphics you saw. And today I'll be talking agriculture in a very like a large scale way, like in its completeness. So we know agriculture is not only rice or wheat or something. Agriculture is like 7 different things. Row crop agriculture, that is all the grain we are producing. Then pasture, fodder, and forage agriculture. So that actually helps your cattle and goat, sheep to grow well. Ruminants, they grow well. Next agriculture is horticulture, which should be emphasized more in India, like mango orchard or whatever other orchards we do have. And silviculture and vegetables are part of it. Horticulture will help us really give more worth compared to row crop, your grain production. So we need to think that way. Silviculture, that's forestry, agroforestry, timber production, medicinal strawberry, etc. And pisciculture, the fish. Fish, we are abundant in India. So we need to really research more on fish. And then grow fish. I still recall the Andhra fish in Odisha we are still using. Odisha has a fisheries program. Last time I went, my friend, the vice chancellor, he was so worried that the fisheries program may close down because we are not doing research. Andhra fish is coming to Odisha and it's just everybody is after it. But Odisha has ample coastal village. So I know fish production can be done much easier and much better way. Then the animal production. So let's go. So these are some of the initial stops you can use AI application in agriculture, like forecasting, predicting, optimizing, decision making, classification, grouping, clustering, so that you know agriculture, like the grains from weed or bare soil. So you can separate them out. And parameter estimation, like which parameters will help your crop to grow faster. And detection. So you can, detection is very important. That I learned in United States when I joined NDSU. The department head first time I asked me, Sudhanshu, do you know how much people is needed or manpower needed per year in Indian agriculture and compared to in US agriculture. I told sir, US agriculture I do not know, but India I know, because I'm from a farming family. Almost 10 manpower per year we need for 1 acre of land cultivation, from seeding to like harvesting. I told I do not know US. He told me one person, and I saw in my I have in my eyes that 1,000 acres of land can be managed by one single person in a year. So how many times we are efficient in agriculture in India? Now we are getting better. So 10 multiplied by 1,000. So 10,000 times we are inferior. We are not managing. Why? They are using this AI, the IoT and all these things to detecting the scout. They are not doing scouting by walking. They are not finding a weed, taking it out from the your paddy field and throwing to the side embankment, guys. So there is a way they are working, and we'll talk about it a little bit. And this is the decision support system tool. So this is very important. So as I told, agriculture is farm to your plate. Now we need to talk about how research should be. Research should be computer to your field. So if you have computer to field to plate, then that would be real agriculture research. So today's topic is how to bring things from computer to your field application. And one more thing I need to emphasize here. Most cases research is kind of publish papers and get promoted or get some better job or something. We should not do research that way at all. Whatever research we do, that research must be reflected in practical way. People can take it, use it, and do better things. Whatever we are proposing, that should be reflected in the field. So that one is today's talk's emphasis. And DSS, another part of DSS is like you need to involve stakeholders in your research. Don't think that you know everything. We know very little, man. So if you go to field, talk to a farmer, you might be thinking they have no college degree or something. They will just amaze you by giving you suggestions. Because they are the people, they are working in the field every day. They know what is the issue with them. Research gets better if you understand the issues. By reading a book or by talking to few people, you cannot really be a researcher. Or by reading some people's work. Some people's work will never make you smart. Talk to ground people who actually do the work, and you will be really understanding how research you can do. So that's the reason the involvement of stakeholders is important. I will be just briefly telling later. So whatever research we do, our goal should be making it a very simple tool. So that tool can be used by a lay person. They can click on something and they can understand things in their own way, not like in your research mind. Your research should be in the background. You take it, make it a smaller tool. And the tool, one more thing I need to tell you, tool should be not a black box tool like a Python script or something. It should be a tool like mostly your, say, Microsoft, your studio, Visual Basic Studio type form or something. So that way people will go click something, click on the execute button, then it will give them some result, it will show up. You can get a map showing up if you click some button. That way the farmers will be, non-smart in our way. We think they are non-smart, so they will understand it. So that DSS part must be included in any research we do. And AI machine learning is the main part. And nowadays the DSS for agriculture is web GIS. That's the Geo-AI. So we need to find out a way how to develop a web GIS site so that people, everybody has a computer or laptop or not computer, laptop, like a phone. They can go through phone and just browse and check what is the result coming, what decision support I can get, and how can I apply in the field. So these are the 5 areas. I'll give you 5 research topics. Row crop like peanut production, pasture production, Sericea asparagus. It's a I need to take time also. It is like a miracle fodder for us. And we are working on 2 projects from USDA and IFA, OUAT, Mahendra and Dr. Panda. He's now Dean Research. He's involved in that. So this crop is a nutraceutical crop. It is very nutritious for ruminants. We are working on small ruminants like goat, sheep, but we'll be checking with cattle, with also elephants. We'll check how healthy they will be. And this one can grow anywhere, everywhere. Like it's a miracle kind of crop. We even didn't know, I even didn't know until last 10, 15 years. Ajit Babu and I are involved with Tom. He's called Grassman in the world. He's working on this for long, 35 years. And that's even, I found out it is native to India too. It's Northeast India native, but we never know. And it can be growing in the worst ever soil. And Odisha has more than 40% soil, which is kind of acidic soil. It grows very well in acidic soil. I will talk about blueberry production optimization with very high-end AI, Geo-AI, and loblobby pine. Like we are using remote sensing data to manage the forest health. It's a NASA grant I'm working with. And trout, this one is a project, Arus, my student there. So he and I worked on it. We found out here, like I'm talking about how to get research ideas, practical ideas. Like I'm living closer to a dam here, Lake Lanier Dam. Below it, there are 2 hatcheries. So suddenly one night, they found out millions of hatchlings dead. And we had a 3-day river corridor management meeting with Army Corps of Engineers, and I was the only faculty invited. And they have like platefuls of things to discuss, but someone started in the beginning that it's a big issue. And died. Entire 3 days they discussed. We could not figure out how and why they died. I went to IIT Guwahati. They are in the conference I just talked to in a discussion. And one of the professors told, can you check? It might be ammonia. Ammonia was not in my brain, guys. This is the way research works. Why ammonia used in your refrigeration industry? So the temperature drop due to ammonia may be happening in water. And we found out exactly what is happening. And that research, and we use like AI to make a model to figure out on daily basis where ammonia amount is in that location where the hatchery is. Then small ruminant production, that one is a app we are developing so that we don't need a veterinary doctor in rural areas where they are not even interested to even go there. So in rural areas, through the app, we can know when the goat and sheep got sick, and the farmer will just use the app to send photos of the eye. Based on the color, you will know exactly what disease it has, and then the medicine will be prescribed through that. And it's a proven thing. It's a scheme called FAMCHA, FAMCHA. The 5-point color scheme is developed. It's a worldwide thing now, based on 2 researchers, FAM and CHA. So let's go quick. And I need to take 2 to 3 minutes for each because it is full of visualization thing. I'm a GIS guy. So if we know, we'll talk about it later. I'll just stay in 1 or 2 places and talk about in every project. So here, when you start a research, your goal is to understand exactly what is the issue there. And once we get the issue, our next thing is to know what are the parameters is involved to solve that issue. And parameters should be in geospatial data way. We need to get them. Because we are talking about Geo-AI and agriculture is spatial. So if we can get all these agroclimatic parameters for the crop production in geospatial format, then we can create our own model and then find out what kind of decision support will do so that we can increase the crop yield if it is not growing well there. So You can check that very fast thing we found out here. So ideal growing condition, well-drained, sandy loam and loamy subsoil we need from soil. And it need calcium-rich soil. So calcium is a secondary nutrient. After NPK, we need to find out how much in which location they are. If somewhere we know calcium is less, so then production must be low. So we need to apply calcium. Instead of applying calcium everywhere, we'll be applying there. Then climate condition is at least 5 months of warm weather. And we are doing in Georgia. In Georgia, in every places, we don't have at least 5 months of warm weather to produce your peanut. And 60 centimeter of precipitation or more during the crop season. So crop season, so that much water we need. But all these data you might find in a numerical format. So your immediate job is how to convert them into spatial format. So there the Geo-AI comes. And there are softwares. You don't need to even write codes in many things. Nowadays, coding is what? You just go to a library, download something, and modify a little bit here and there the syntax, and then it works. So coding, like AI, is making things. Even entire code you can download from some OpenAI source also. But I'm not talking about that. So we can use software. If the software doesn't have a tool to do our pre-processing of the data, then we can write a script on it. And that script writing is easy. As I just now told, you don't need to be smart. You just need to have interest and time. So that way you can do it. And today's age, things are so easy. Our time, we need to go read books from library, spend hours. You don't need to. Even these information, what I'm writing here, this is from reading people's paper and all these and talking to here 4H people. 4H is an acronym here, like this is your agricultural extension folks. So we found out those things. Talking to farmers also. You don't need them. You can just even talk to ChatGPT, or Google Gemini. It will just spit out point by point for you, even explaining everything. So take advantage of that. So then we found out the conditions in Georgia. There is another issue here, aflatoxin. Ajit Babu told this is a big issue because, and I didn't know even how aflatoxin really impact things. If you got a peanut pod, you will find only dust there. When you open it, dust there, the peanut knot is not there because aflatoxin actually eats it up. And we found out you need to know before harvest, if 3 weeks temperature remain really very high and your soil is too dry, then aflatoxin attacks. So we need to have this kind of streaming data also. We need to know exactly before the harvest date, 15 to 3 weeks, we need to check whether it is dry condition or not. Remote sensing can tell us. So that Geo-AI comes there, you can get remote sensing data and analyze and get it. So these are some of the objectives. You can see now we took here where peanut is produced in Georgia. We have a CDL data available in United States. It is from NAS, National Agricultural Statistical Service. They created a geospatial data format every year, which plot-wise, what kind of crop grown in United States. So we took out the peanuts, and peanut is being grown here in last 15 years. So we add up 15 years of data and find that. I'm going quick. So these are the data sources. We are lucky in US to do research. You can get authentic data that easily. I'm working with Indian students and faculties. It's not that easy, but we are finding always a way to get the data. We are finding a way, always creating. So, and this is the entire format. You check that data processing, we create the model here, the Geo-AI supported model. And then we have the aflatoxin-based information, and then took it out, 15 years of data. This last map is showing where your new agricultural, new peanut producing area could be used. Because aflatoxin is really in the south part, peanut is grown well, but now south part is being attacked by aflatoxin. So these new end product I gave, they can move to higher up and produce peanuts there. And they can get better yield because the soil and other climatic factor is like positive there. And these are the way how you do. I'm going faster. Like you create all these data. Then this is one thing. Also, this is a new innovative idea I put into research. It is called Delphi method. Delphi method was used in arts research mostly, like sociology and all kind of things research. But I bring it to engineering research. So here, because you have different parameters of soil in spatially. So one location has, say, sandy loam soil, one location has loam soil, one location has silt soil, something like that, or silt loam soil. So you need to ask experts, 15, 20, 30 folks, in your opinion, you grade what score I give based on your knowledge, I should give for agricultural production. And because you have different people who are talking, different people have different thought. And in the beginning, I told a sole researcher, one person cannot be a good researcher. And one smart guy cannot make good research. You need to talk to farmer in the field. You think they are dumb. They are not. They are 10 times better agriculture scientists than us. Seriously. And you get more information from them. Using all these information, you create the score or create the weight and use those weight into your model to find out what you can do. Like what would be the way where the best production areas are there. So these are the results. You can see I'm going faster. This is the map peanut production spatial suitability map of Georgia. So these are like 5 scales, green to red. Red is not suitable. Green, dark green is more suitable. So there you go. And this is the peanut production in 15 years in Georgia. You can see we just 15 years of peanut data we took where they are produced, add them together. This is the entire area. And we took out that area from the probable production area and find out these are the new production area can be. Okay, let's go. And summary conclusion. There is another one. This is my PhD work. You can take image of soil, image of agriculture, like mid-stage agriculture, then other agroclimatic data, and then you can predict even how much water is needed for the crop and what time. That can be done. And Sericea lespedeza, I already talked about it a little bit. You can see Ajit Babu there in the field. Ajit Babu will be coming later. And Sericea, as I told, it was also India native earlier. So, but here, India native. And we need to really grow that. And here, how we use the similar approach we use. We are doing 3 state and finding out this is Ajit Babu here in the field. We go always in the field. Even in US, I never sit before computer. Whatever I do as a field work. And we are flying drone. This is the new one here to talk about. The drone we are flying to find out like differentiating between I'm coming back. I'll go back later. So this is the image we are taking during the bare soil period. We prepare the field and find out the soil from the image itself, drone image, what kind of extra nutrient needed. For Sericea, we are not worried about. It doesn't need any nutrient. It fixes nitrogen. It goes deep to get phosphorus. Root is very deep. And also it creates better soil due to falling of the foliage. And we have checked it in South Africa. One farmer put Sericea in one of the worst locations. Now he's telling his sons and grandsons, they are asking, can we grow corn there? And he's not letting them grow. Like a large acre, 100 plus acres area, and he's not letting them grow. Because in 15 years, the soil becomes so fertile. Yes, and this one is the research. We are talking about the tannin, why it is that great, why it is the fodder is your miracle fodder like nutraceutical, because it has a tannin chemical content which is best for clearing out all pathogens in the digestive system of the ruminants. And that is not my research, it is research of biotechnologists and other folks. So we took the data, we found out, like make a neural network model to find out whether based on the climatic and other factors, or spatial factors if the tannin content is increasing or decreasing in that. So we create a correlation model. And this is the way we are now testing for the biomass. We are going to field, and we are like cutting out the samples and weighing them, and then using remote sensing data, we are creating a model where biomass is increasing or decreasing based on the other factors. This one I was talking, when we take the drone image, this is the field where Sericea is there, and we have also weed inside. So the image analysis I used here, like we use LCI and also CP2, NDRE. I do have algorithms for image index development around 150 plus. So drone image, you can take, drone is useful now because you can take spectroscopic type image. Like every nanometer, you can get images. And all these 100 plus your indices I'm talking about, they work with individual nanometers. So you can take those nanometers and create your index image. And from that, you can easily find out exactly disseminate or differentiate the weed from the your like the crop. And my next goal, innovative goal, is to write a script into the drone software so that when you spray, so it spray only on the pointed way. It will fly, take image, analyze the image, and find out the locations of the weed. It will spray on the weed. So that way we are environmentally safe, the weed is killed, and crop is better growing. So that one AI machine learning will do. That is our next goal to work with, whatever we are doing now. And these are the way you already saw earlier. So these are different parameters you are seeing. These are climate parameters. Lucky in US, you can get all these data in spatial. If it is non-spatial, it is easy. We can make it spatial. And then these are your soil parameters. We have the G-Sorgo data to use. It's a your raster data, and easily from raster we can create individual parameter rasters. And these are your other environmental parameters. And we put together everything, and then we make models. And this one is the biomass model, that neural network and statistical model I was talking. So, and I'm going faster. This is the final model to tell us where your Sericea will produce better. I'll go quick. Yeah. So now these are the Delphi-based scales, and these are the Delphi-based weights for each parameter, because each parameter doesn't contribute for the crop production same way. So we talked to a bunch of people. One parameter is 5%, another parameter is 10%. So we took the average and put it out there. And this one is showing like all. So I go. So all these data, we have the scale-based data, how they contribute, and we multiply them by the Delphi-based weight we got, and then it provides us, this is the result. So here, the lowest are the redmost ones, and greenmost ones, Sericea can be growing well. Even if it is a miracle crop, still it needs some kind of climatic, other agroclimatic factors. And the next thing to add here, guys, once we finish this, it stays in my computer. But how it help farmer? So you need to create a dashboard, like a Geo WebGIS dashboard, so that farmers can get access to it and they can know it. And you can make it dynamic, like farmer can go click on their farm and they can check immediately every information about their soil, all information that he can get. And it will tell him, your location seems like not good for Sericea, but if you change these things, then you can grow Sericea well. Any crop, this is similar to all other crops I'm talking. You must have this kind of system created. That is AI machine learning can help us. And this should be useful to farmers. So let's go to blueberry. This one I'll go very fast. This is very advanced image segmentation approach. And some young kids, smart kids, you need to think about, other professors also, other researchers, think about using this one to apply in any kind of agriculture. Because finding exact things in the field is not easy. Even if we scout, you just walk, you can miss things. But this one will not miss. And you can check, we use Ecognition software, which is actually one of the very advanced machine learning based image processing software. So we took, but you have to write your rule sets there. So based on the rule set, you can get it. So these are the red band image. We separate the bands. We created principal component bands out of it. And we created the Savi image. And by the way, one thing to note for everybody, I found out the Savi for agricultural images works better to classify segment than the NDVI or the normal band images. So every time you want to do a classification of an agricultural plot, create a Savi. Savi is called soil adjusted index image. So soil adjustment is there. So that way you can classify it well. And we created a water index also. So that way it tells where soil moisture is higher, soil moisture is lower. And these are the rule sets. Like how it does, it take out one parameters, like find in the entire field, we found out the tall structures first using LiDAR data, like point cloud data. So we found out what the big trees are. Then next we found out the buildings, like comparing the building shape to a tree shape. So this is the, as I told, it's a very advanced machine learning or AI approach. So we can use the shape of the like image grains and then tell this would be a building, this would be a tree. So like your rule sets, step by step, we disseminate or distinguish individual features there. Then we found out evergreens, like from the trees, which is evergreen, which is deciduous. Then we also find out where the tree gaps are there. Then we found out building. Then we found out water. Then using other algorithms, you can plug in any algorithm-based images into it and newer data into it and use that. And not only spectral basis image segmentation, you can do textural, you can do any kind of like your geometric wise, all kind of things we can do. You will see them there. And then finally, we found out two different type of rabbit eye and high bush blueberry in the field. So you check that. This is the coding. This is simple rule set based coding in that software. It's a crazy good one. Now you check, this is the GBI image. I'm going faster because I don't have time much. All these. So let me start where it starts. We did it for 4 years. So now tall and short feature separation. You can see that. Red and other color. Red is finding out all tall structures. Then this one, like differentiating between various classes of tall objects, like buildings. So this red one, building, tree gap, building, and your tall trees. So this is the building and some of the gaps here, you can see. Then go next. Then the shadow separation, because shadow is a very big deal in like your image segmentation process. In any environmental data you take, shadow will completely, you can tell that it might be water, but it's not water. So we found one approach to separate water to shadow, that the water index we created. So that way it can distinguish between. And you can find out also, you can use your AI like rule set that if there is a tall tree here, then the shadow might be here. You can write code that way, just like the English way I'm speaking. So you can write your code the English way, like just plain English. Now it's a bare soil classification. Then we have a high bush blueberry variety distinction. Here, NDVI 0.2 to 0.4, that tells us it is high bush. Rabbit eye will have a different your NDVI values. Then rabbit eye blueberry variation, compactness greater than 3, we use that. And this is a chessboard one I was talking. You can create a geometric features based on the chessboard. The chessboard actually helps us to find out differentiating between high bush and rabbit. Rabbit eye goes taller and shorter bush, and high bush is like very large bush. So that way you will find always like a very kind of a large your rectangle or polygon, and that would be your high boost. If you have shorter polygons, smaller polygons, then it would be rabbit eye. You need to think. Research is thinking. No book can teach you be a good researcher. Remember that. Not a single, like we are following other people's work. Yes, of course, it gives you some idea. But when you do research, you use your own mind completely and think in a practical way. Bring the field knowledge. I tout myself as a one good researcher because I do have field expertise. That my village route helps me to do good research in agriculture. So we need to have that to be a good researcher. Only reading books or just getting 5 out of 4 GPA will not make you a good researcher at all. So you can get good job, you can get high salary, it doesn't matter. But good research with practical, physical knowledge we need to. Okay, let me go quick. Now you can see grass classification. And this one is classifying building, deciduous, evergreen, grass, high bush, rabbit eye, short like herbs, then soil, tall trees, tree gap, trees, vegetation, and water surface. Vegetation is like your other than the grass vegetation. So we can do that deep. I didn't publish all these things. These are all done like it is in my computer. Unfortunately, I don't have time. So I don't have grad student or somebody to help me to publish it. So, yeah. So now this is the yield model. So we are using all these like GVI mean, NDVI mean, SABI mean, water availability, pH, because blueberry, you know that it very acidic soil, it grows well. So blueberry is a good plant we need to grow in Odisha because we have mining area, and blueberry is one of the antioxidant and very high value crop. And ball density should be high, but the soil should be loose. It should not hold water for longer. Then you can get better yield. This was my NASA grant when I come to Georgia, the very first grant I got. So, and we did model and find out the similar way. This very high 80% correlation we got, guys. Check that. Like other parameters we use to yield. And yeah, didn't publish. The next one is forest management. This is the NASA grant. Just now I'm working. Unfortunately, the second and third year money got caught, but we are finding some other source to. Here research is in US is getting troubled, guys, if you know or not. So like research fund, but now lucky for me, they are funding practical research. Most of the money, I have 7 grants. This is the first one got caught. First year money they give, second and third, rest of the fund is not caught. They are all there. But most of, lot of folks got their projects gone. So this one is a huge project. We are using SMAP hydroblocks and EcoStress data. EcoStress is a satellite in International Space Station. So it takes images. It tells the evapotranspiration amount, real time, how much. But the EcoStress being on the ISS, it doesn't have a like a fixed temporal resolution. It fly over your place maybe at 10 a.m. Today, after 3 days, around 3 a.m. So what EcoStress people in NASA JPL doing? They are taking all the data. Yeah, I'm finishing quick. So I'll take 5 more minutes. I'll be done. Then we'll go for question. And then they are processing the data, providing, but they gave us fund to check whether it is actually reflecting in the field or not. So we have here eddy flux towers. We are 90-meter tall towers on the forest cover. So it takes all the climate information real time, and we compare it. And then we found out 15 locations in south, so in the north. So we are using and making an algorithm there. So, and this is the approach here. And we already developed 70-meter resolution to 10-meter. My student should be here. Akash is from IIT. IIT Bhubaneswar. So he developed the algorithm or the process how to do the image fusion to bring 70-meter to 10-meter. So every 10-meter we can get information, the ET information. And also we are also in this project, we are separating evaporation to transpiration, which is very difficult. And with remote sensing data, the eco-stress data, we are also getting evaporation and transpiration same time from a 10-meter pixelated area. This is the work, and we already developed algorithm using your random forest because the statistical model was not giving that good result. But now we are getting better result because we are using more and more data. So finally, we have an algorithm which can transform the eco-stress ET value to actual field value, so that NASA can use our algorithm any forested cover area. We are working on pine forest, so that algorithm will be used. That way, the conversion will give us evaporation, transpiration, and forest floor evaporation, canopy transpiration, and actuality from there. So there you go. These are the eco-stress thing. This is another project I wrote. I didn't get it. This is a land surface model. This is a supercomputer computing process is there in NASA, JPL. So they take all the data and spit out the result. So I wrote here, find out the drought condition and wildfire vulnerability scaling. So we are working on this one in another grant. I'm working with US Department of Transport. So wildfire vulnerability analysis we are doing. And stream discharge, runoff, evapotranspiration. And these are the data we will be plugging in. We'll be using their own supercomputer to do it. And this is the graph. I just showed it for you. So, but I didn't get the grant. Anyway, so soil moisture condition, eco-stress can do, SMAP can do. This one is the modeling determine contaminant for fish hatchling. I already explained this one earlier. And we did that SWOT model to find out which location is getting more ammonia. And my high school kid, he's going to college now, Arus. He is a geek, like in computing geek. So he used Prophet model. We are talking about AI. What is that? Your Facebook AI. So they have a Prophet model. So he used it. We even tried to not to use a cumbersome SWOT model. We just use historical data which is available in India and then predict for future where in every location how much temperature change will be happening every day, or moisture, your DO change, and or ammonia and all these things. So that would be a revolutionary thing we will be finishing up, because SWOT model is very, very cumbersome. Sometimes it runs, sometimes it doesn't, if you do not have correct data. But this one, just plain historical data and work with. And India, I cannot confirm, because India, I do not know whether we have historical data or not. US, we do, USGS gauging stations are there, we can get those data. Where there is not, then we will be figuring out another AI approach to simulate in non-gauged locations. There you go. I'm going faster, I'm finishing. And this one is the AI model. I already explained what we are doing. We are creating a cell phone app. So that way, in that app, the main focus is the goat and sheep are wearing transponders. The transponder actually provides minute by minute data based on their movement. If they are grazing, then certain data will come. If they are sleeping, certain data will come. If they are running, certain data will come. So this is the big conceptual model. And you can see, here is the data. You can see when they sleep, they have low, like 0 to 40 signal. If they are grazing, it will come 40 to 90. If they are running, more than 90. So we took this data, we analyzed everything, and created algorithms already, so that if the data happens to be, the goat is there in the field in South Africa, in the server, it will immediately analyzing if 4 hours, within 4 hours, sleeping time, it should be 0 to 40. Now it is showing more than 40. That means the goat is really not sleeping well. So that means it is just moving around or something. So that way it kind of sick. Or during the grazing period, if for 4 hour period, if the goat is having a low signal, means it is resting much longer time in the field instead of grazing. So that means it is sick. So then it will trigger the app, and a message will go to the farmer, because tag wise we know, transponder tag wise we know which farmer goat is that. The farmer will get a message that, hey, your goat seems like sick, can you go and check? He will go check if it is sick. Then can you send a photo of the eye color? The eye color photo he will send. I'll come. Yeah, this is the coding you saw. And now we are checking the eye color, and eye color comes. We already processed it. And then eye color wise, you match with the 5-point scale. We are just showing for publication purpose. And our code is there already. And that way it will tell this disease and this medicine. Medicine is already listed in our program. Then a message will go to the farmer's cell phone. Hey, this medicine you buy and give it. You don't need to go anywhere. So that is the project. And this is all about today for precision agriculture. So what I mean to, we need to use artificial intelligence and machine learning with emphasizing, with field knowledge, not book knowledge, to make a good research. Everybody in CAET, guys, the students I'm talking, most of us are from farm families. So take advantage of the farm, like talking to dad or talking to mom who is doing the farming, or somebody working in your farm. Get information, use into in your research. Do not superficially just read the book and go to exam and get 80 out of 80 or 100 out of 100. That doesn't make you really a good researcher at all. You can be a good student, you can get a good grade and go to somewhere. It doesn't matter at all. In today's era is practical research. That is the reason most of the guys are really scared whether their job will be there or not, because AI will eat their jobs. But AI cannot eat our job, guys. So I'll stop here. If we are practical people, AI cannot eat the job of an agriculture engineer. So my advice to all of us, go to field. We think like a farmer and do it. I'm stopping here. I'll take questions. Thank you, guys. Thank you for giving me opportunity.
Thank you. Thank you, Dr. Sudhanshu. We are open for questions. Professor N. Panda.
Yes, sir. Yes. Thank you, Sudhanshu ji. Yeah.
Thank you.
I am at your hometown, sir. Sir, I am in the the village. You are there, Dr. Sudhanshu. I am in the neighboring village. I am in the village now. Yeah. With the mobile, I am assessing.
Okay.
Yeah. Ovana. Yes, sir. Okay. Yes, I am in Ovana. And thank you. Nice to see. And after and really from the peanut to blueberry and to fish, it was there, and very good can be done in our Indian context also. Starting from the peanut or fishery or Sericia, whatever we are doing, it is a very good means opportunities there for India as is concerned, and especially Odisha is concerned. And as far as you are telling how the transponder is helping the animal to detect it is or lying or sitting or like this. So I appreciate this and how, but as far as India or Odisha is concerned, we have not that much in a primitive stage for AI development like this actually, ML. And we have not that much data to make like this. We have to see, and I appreciate your concern. I am the same time, you should go to the field first. That is first important thing I got, and I follow that also, and see the farmer's problem. The farmers is defining his generations. He knew how he is defining his technology also, redefining his technology, his problems. Because he know what is his problem and how he is refining his problems to a different way. So from that you can have the know how you can go your research actually. So I am always in favor of that actually. And as I have worked for more than 12 years in the Krishi Vigyan Kendra, which is the farming system, and my academics also, that's why I good practical knowledge to my students actually, and also research also. So you are very right. You can be very.
I actually talked to you, so I know how your research.
Sir.
Yeah, thank you.
Sir. Sir, my academics good is only due to my good extension and research actually. If your extension is good or like if you know, your research will be good, automatically your academic will be good actually.
100%.
So thank you, sir. For your bhai bhi mu dakuji actually, I am calling also. You are just 1 year senior to us, and neighboring village. The same village, in the gentle breeze I am sitting with this hot summer. There is good breeze is coming from the sea. I am just outside. I am seeing and just sitting. Yeah. Okay, thank you, sir.
Thank you.
Yeah,
Thank you,
we will
Professor
meet
Panda.
actually. You are coming, I think, India. Yeah.
Yeah,
Yes, sir.
I'm
Yeah.
coming in
Okay.
June 20th. So 25, I'll be in the village. So I'll be in Bhubaneswar.
Yes, yes.
Thank you.
Yes, yes.
Thank you,
Okay,
Professor
okay. Yeah.
Panda. Sudhanshu, I have a very
Yes.
generic question for you. You have been
Go ahead, sir.
working both in the US as well as in India. Besides the absence of data, if we to put it that way, besides that absence of data in India, what else have you found any other constraint for doing your research work here?
Yeah, I am. That's a very good question. I have practical knowledge of data deficiency and also uh, like problems doing high-end research there. So IIT Bhubaneswar, that AHRC, I think you heard, and a few of us are already part of it. Panda sir is kind of spearheading the AI in agriculture stuff, SN Panda sir. They are my first thing I told our group, because we are working with IIT Ropar. They have a your AI in agriculture, huge grant government give to them. I went there and presented. First thing I told that we need to have some IoT system there. So I need to give one example. We are having weather stations in the blocks, and where it is a block headquarter. Block headquarter is urban. It is not agriculture at all. And if it is be running in the block headquarter, it might not be running in the farm field. So what do we do? And
Correct.
when I ask why we cannot have in the farm, because somebody will take it away. If somebody take it away, then we need to find a way how to save it. One simple example I'll give. I was in soil conservation department as a soil conservation engineer for 7 years. So we go plant saplings. Next day you go there, goat already ate it. But when I did my research in AIT, in the same area I did research, I found out amazing thing, and that is again practical. That was the USLE model. I wrote complete coding to do it and did a comparison of 1989 and 1996, 7 years comparison of your land use in that 181 square kilometer area. Find out the health of the forest is improving in 7 years. But I saw when we plant sapling, sapling is gone, it by eaten. And where it is getting better, the cause I also put in my research, in AI research, they have a community, like village community created in those areas. The village community folks, they will never let a single cow to get inside the forest. They guard the entire thing. Forestry department, what they do? They create the ditch like 4 feet ditch, but ditch is not that wide. Like a rigorous cow can jump over it. Like a smaller calf may not. So the ditch are for heck of it there. And many percent the ditch is already not even complete. So there will be like soil there still. So they walk over there. So that was useless. But the community, village community, they help those area where I find in 7 years the forest growth is better. Like your what do you call small shrubs become taller shrubs. Those things I could distinguish, and it is there. So these kind of things we can do in, if we have a weather station, give somebody village person, hey, you are in charge of it. You don't need to pay. People will be coming out for free voluntarily to save it if you explain them why this one is there, how it helps the entire village. Another example I give in that, in my village side, when I go from Jharta Chako, Panda Niranjan Babu knows, Jharta Chako to go to Avana, the trees are standing like crazy. Last 40 years, I never see government will go plant trees, it will be not there. And the last government, I asked why. I asked my villager. They say last government, Navin Patnaik give village person, hey, you are in charge of this 10, I'll give you some money. And if all the trees are standing now. And 40 years, 50 years, we are trying roadside plantation, nothing working. So that kind of thing we need to do, first thing. The second thing, we do not have a good soil map. So we need to create a soil map. So we are working, there is organization there, but those are not really the USDA soil map type we are using. So we need to have it. And those kind of smaller project we need to do first, then go for AI next. That way all will be successful.
Thank you. Anybody else? I have not seen. I see Suranjan Panigrahi are here.
Hey,
Sir,
Sudhanshu,
namaskar.
hope
Sir,
you
namaskar.
remember me.
Yes, sir. Yes, sir. Namaskar. Namaskar, sir.
He is one of our proud CAET students who decided to come and work with, and Punyatya Mahapatra is the second person. Sudhanshu, you did a very good presentation.
Thank you, sir.
When you mentioned about your PhD work, it is always a good thing in a public international atmosphere that who funded your project, because that is our professional obligation and responsibility.
Yeah, that one was funded by NASA. Like you,
because that gave us money. So otherwise, we could not have done the work and got not the PhD, right? So just a simple thing. So another question I want to ask you, is that you did a nice work, and Debu is doing an excellent work in organizing all these people. Today I found his email, and I thought, well, we'll go and see all these nice people, colleagues, people are here. So when you do the animal model, that is nice work. But do you know that if it is FDA approval is needed before it is used by public?
Yeah, we have not done in United States yet. So your goats and sheep are in South Africa. So we are streaming the data, and we are not harming goat and sheep. They are just using collars. Here in US, every animal have collars in the ear or something. And we didn't think about FDA approval here. If needed, we'll be doing. But all these goat sheep, I showed the data and analysis is from South Africa. Data streamed to my office computer and we analyze here. And then, yeah.
Yeah, because FDA has already made a rule that any software you develop for diagnosis or prevention, treatment, you can go to FDA site. So they call software as a medical device. So a lot of time people mistakenly use app for consultation, for prevention, medical consultation. So, but I just wanted to know whether you guys are working very good work.
Yeah, sir, we are doing it for last 10, 15 years. Yeah, we are concerned about that. And that too, this one, like the premise of this research we started in rural areas, I told very clearly, because I'm a village guy, I still have village mentality. Lot of folks, and the idea, even one in conference, I told my mom died because of such thinking doctor. That guy is from my village. He will stay always in Baleswar. He will never come to our dispensary. 6 years. And my mom, when he has heart attack, and he will get medicine for gas. Because there is a metric fell guy, he has a medicine store just in front of the dispensary, or it's a hospital, 10-bed hospital. And he will give again his gas, and this guy never checks. So this is the situation happened in South Africa.
Sir,
yes.
Sir, can I add one more thing, sir? Yeah. Huh?
Go ahead.
In this respect, yeah. Sir, actually using this transponder or like this color, huh? Sir, we are just knowing the preliminary things, not a very means chronic thing. Huh? Yes, sir. Very just preliminary thing. Is there any deficiency of the, because mostly you are deficiency because you see in the early doctor, see your eyes first. Your conjunctiva is good or not. Means your iron is the root. Yeah.
Right.
Yeah. So mostly it is a hemoglobin deficiency or you are able or not. So the doctor will not prescribe. Just a primary information, and further you can go for see the doctor actually. Yeah? Prescription only from the doctor. Yeah. Just sir. So for the I think
Niranjan Babu, you will understand that the PHAMACHA that I told, the 5-point scale.
Yeah.
So that's a 20+ year like a scale, point scale system. It is being used widely worldwide. So we are having a group here, SPRSC, a group. So we discuss about it. So these are all science-based. Yes, of course, we are not doing it for a human or something. If it is, we'll go there. So this one, actually, we use technology to know when the goat is sick, and then we take a photo because
then accordingly will exactly.
Yes, exactly. Yeah. And
so finally the doctor will treat actually. Yeah.
But animal disease is under FDA.
Yeah.
So
sir, it is sir. You are right, sir. But we are just a preliminary information we will get actually. He is sick or not. Accordingly, doctor will prescribe later. This is the symptom is coming. Yeah.
Yeah.
We can directly go from the app and give the medicine. Yeah.
Can I intervene here, please?
Yes, sir.
We are running out of time, and
yes, sir.
There is one hand raised.
Yes, sir. Okay, sir. Okay.
Sanjay Swain, please go ahead.
Sir, namaskar, sir. Sir, madam, namaskar. Sir, this is Sanjay Swain, a forest officer. Sir, जोटा आपण प्रेजेंटेशन बेले गोटे कहले जे जो ये कैटल प्रूफ ट्रेंड फॉरेस्ट डिपार्टमेंट करूनी बा जोटा करूची खंडिया रखुची सर सेटा ऊपर मु जस्ट गोटे कहया पई चाहूची जे सर जनरली वी आर कंस्ट्रक्टिंग एलिफेंट प्रूफ ट्रेंचेस actually elephant proof trenches they are like trapezoidal channels. The top width is 3 meter, bottom width is 1 meter, and the depth is 2.5 meter. So it is really difficult for the elephants to cross the elephant proof trenches. And also in some cases I know that we are constructing some cattle proof trenches, and cattle proof trench we are using the funds from Manrega, VBG Ramji scheme, and some other schemes. And as far as the my knowledge goes, we are completing that. ଆଉ ଯୋଉଠି ବି ସାର୍ ସାର୍ କୋଉଠି ଟିକେ ଯଦି ଆପଣ ମତେ କହିଦେଇ ପାରିବେ ଯେ କାମଟା କମ୍ପ୍ଲିଟ ହେଇନି
Sanjay, hold on. Sanjay, I was talking about 1990s in your Chitrakonda area. So,
actually, yes, sir. Actually,
1990s
area that is a difficult area.
You might have done it. That is good. If you are correcting it, that is awesome. But why it was not working? Like Sanjay, you need to check this one. You need to check.
Yes, sir. I will check it, sir. Yes, definitely I will check it because our Chitrakonda area is a little bit difficult area because you know that. Sir,
difficult for
affected area.
Listen. Difficult for most of us, not for me. 4 years I worked. I'm the only engineer having malaria. I was there a 4-day week. I take 30 kilometers by boat, walk 8 kilometers. Area was around vicinity 20 kilometers every day I walk.
Sir, definitely, sir. We will check it. Under which scheme funds were released and what is the progress of work. Definitely, I will talk with the regional chief conservator at Korapur. I will talk with him. And the second point, sir, you were telling some plantations, the roadside plantations are incomplete. They are not doing in and around Bhubaneswar city. What I remember from your speech. So, sir, actually, the roadside plantations are being done by our corporation wing. And in many cases, the plantations are successful. Still, if you have a specific concern, which area, which road should be taken up, sir, definitely I will
I don't have any concern.
At the right time.
I do not have any concern.
This is a really, sir. A very noble idea, and this is a very much helpful for our environmental conservation. Definitely, sir, this is a good idea, and I will request you to point out those areas, and definitely I will talk with the forest headquarters.
By the way, Sanjay is talking to everybody, not me. And whatever information I got, this is my 40-50 years of experience.
I am talking to everyone. This is
everybody, yes.
Sir, definitely, sir. Usually, I attend this tea talk. Right now, I am at Phuket. I have come to Phuket for a small trip, and I am attending the meeting.
Good, thank you. Sanjay, we will talk about forest management in detail later. Okay?
Yes, definitely.
Sanjay, we have 2 more questions to go. Ayush, please go ahead, please.
Yeah. Hi, Dr. Panda. Thank you for the presentation. It was really fun, interesting. I just have a quick question. So for like the project that you talked about, would we need to do like NDVI mappings, like as a first step, or would it be a crucial first step for the research projects?
The NDVI mapping is easy because it's a very old thing. You just take images which has NR band and also red band, and
Yeah,
just use those two to create an NDVI map. It's just
but
algorithm is red minus NIR divided by red plus R.
right. But how would you get them in like a remote location where you can't like easily
Because you have Landsat data, say 30 meter, or you can have Sentinel data 10 meter. You can take a drone and fly in remote areas, just take images. And drones should have these images to be taken, like minimum red and NIR should be there. And drone can be flown anywhere, and that's easy. And aerial images are plentifully available in the US. Every year we have, and that is good. It's called NAP, National Agriculture Imagery Program.
Yeah.
Nowadays, every 2 years we are getting, because fund is getting crunched. But you can get since 2005 until today, every state 1 meter resolution. 2005 to 7 it was 2 meter. 2007 to 2025, 26 will come. 2025 it is 1 meter. So you can get everywhere 1 meter resolution, and it comes with 4 bands. So RGB and NIR. So you can create NDVI. But NDVI, I found out it's not that useful. You may think about Savi or M-Savi and other indices. I'll provide you those indices, 70, 80 different type of indices. And drone technology will help us to really get those indices working. Otherwise, you need to talk to NASA. They can fly your to get hyperspectral images, and hyperspectral images can help us create those high-end. Like we have a chlorophyll index to create also with image, so you can know chlorophyll content in different locations. Yeah, we'll talk about that later. That would be maybe our research, coming research. Okay.
Yeah. Okay. That's all I want to ask. Thank you.
Thank you. Ranjit, you have a question? Or no? John Majoy was asking first.
Yes, sir.
Yeah, go ahead.
Oh, sorry, please.
Good evening, sir. I am from I am Dr. Janmej Naik from MSCB University, Baripada, sir.
Sure.
My area actually closely matches with your area, and our Honorable Vice Chancellor Mohendra sir today shared the link to join, and it was a really very nice presentation what I have gone through. So I was a little bit keen to know about the Delphi method what you have shown, because that's the method. Long time I was very keen to use that, but the problem with Delphi method is how it used to fit to the weights of the neural network, because the neural network what you have shown, it is a somewhat semi-complex structure, but at the same time the weights and the remaining complexity of that network, how it is going to affect, and what is the link of no, how you have tried to manage that, the Delphi method, that I want to know from you in a very short way.
Yeah, that is really an excellent question. So, seriously. As I told, the Delphi method was not much used in our type of research. So, because I do Geo-AI research, so there I thought we need to bring it. So, because my goal is always pick brains from others. Don't do, we have a term in Odia, like Joda Baladaku Ghoda, sorry, no.
Yes, sir. Yes, sir. Yes.
Yeah, for that reason, we need to really pick brains and find out. So Delphi actually provides, like people will say, okay, this is my number one, like parameters for this production modeling. This is number two, number three. Somebody will say,
sir,
that one my number. So you can bring that. So all these weights, you average it out and then use in your own model. But coming to your point about neural network, we don't need to provide those Delphi weights, because neural network completely work with what do you call, it's a black box. It's just random weights it picks off every iteration. So those random weights, and whenever this one particular group of random weights helps us to get to the best of the output, then it stops that the best fit model. So that is
True,
created by
sir.
the AI.
True.
To coming to the next part, how to use it. Yes, now the machine learning has improved so much. You can even bring your own weight and plug it into it. We are working at
Correct, sir.
Yeah, so we can take it and plug it there. Okay. Yeah.
Sir. Thank you, sir. That
so
was the
will
only
talk
concern
about,
of mine.
Mahendra is my friend, so my classmate, and we will be doing a lot of good research.
Definitely, sir. Definitely. It will be my pleasure, sir.
Right. Ranjit, you have a question. Yeah.
Yes, sir. Thank you very much for the great work what you have shown in this today's presentation. Actually, I was curious to know about the DSS work. What you have shown. That currently we are using the large data set to develop the DSS. And also some DSS, I mean, like we use also the process-based model, right? The observed data and all these things. So which one should be kind of more giving the accuracy, or like how we should develop so that, the predictions should be precise and more accurate, like integration of that process-based, or if we are developing using the large data set using this ML AI algorithm, so what we need to take care of while developing that?
For agriculture research purpose, process-based data is the best, because this is a field information, remember, okay? So you need to get what kind of data. If you do not have some data, figure out how to create it. If you don't have, you can still get rid of it. Do not use it. Why? Because environment factors are so much for a crop production. We cannot use like every factor to figure out where peanut will be growing well. There might be something happening, one microorganism is present that is helping peanut to grow better. But it's not feasible for us to get it. If we can, we can. We are now working on a proposal. So at Port Vale State University, we have a really good postdoc. So he is working on to find out some kind of microorganisms with sensors in the field. Those are like helping some of the crops we are growing there, or they are helping to create diseases to the goats and sheep. And we are already successful. We got that, and we are working with a company. So my point is, if you do not have the data, we don't need to. Whatever data we have, we need to use that. And accuracy, you don't need to worry about too much, because if you can increase production by 10%, that is awesome. And always we have a tendency to publish a paper, we need to get 90% accuracy. So we pause the data. We just took out all outliers and just make it. That is like BS publication. Like all these publications are nothing. I'm sorry, I'm using the bad word. So only just to show that I did a great research, 99% accuracy I got. That is untrue. Whatever accuracy, if you get more than 50% accuracy and you lucky enough to have 20% extra crop production increase there, then we need to go for it. And process-based model is always advised.
Sudhanshu, we'll take a last question now, and because it's
Surendra was asking a question.
Okay, let's take a last question and wrap this up.
Sir,
Hey, Sudhanshu, you did a very good job. I just want to tell my colleagues who are professors, teachers, students working in MI, ML that Sudhanshu brought a very good point, but please know that foundational understanding is very important. Lack of that is causing our profession, our people to apply this technology without understanding the core. So that's what I just wanted to have a comment. Sudhanshu, you did a nice job.
Agree.
Thank you. Thank you.
Fully agree. Thank you, sir.
Okay. Biswajit, up to you. No, up to you, I said. No, you go ahead, please.
There are some questions in the chat or something. You can check.
No, there are no questions. I didn't see any questions in the chat. So I think we'll close here, and we have already.
Thank you, sir.
Beyond time now.
Thank you very much. Thank you so much,
Dr. Sudhanshu, and all others participants. This was a very interesting session with a lot of questions and answers going in.
Yes. And we will be working really seriously on making Odisha agriculture better. And I am emphatically telling again, we need to go to field. We cannot just sit reading a book and thinking that we are the best teacher, we are helping Odisha or something. That really never helps. Publishing a bunch of paper does not really work at all. Just like Sanjay was asking, because he immediately took it and he is figuring out in the field exactly where he has the elephant trail, like the elephant cannot cross the trench. So that kind of thought we need. If we don't, then presenting this kind of stuff is useless. So it doesn't really help at all.
Well, Sudhanshu and Sanjay, because he's still here, there are other issues. Just making a trench stops the elephant, but it creates other problems. Okay, and then Sanjay is not thinking about that because his mind is not trained to think about that. So the environmental impact is due to, we have to measure the environmental impact due to the elephant crossing the trench versus actually digging a trench. And we have to evaluate both the factors before we take a decision. So,
Sir,
yeah, go ahead.
sir, I want to intervene here. Sir, actually, we are just protecting the human habitations by constructing trenches. Sir, hardly we are obstructing the natural path of the elephant. The elephant path, we are trying our best to keep it inviolate. But, sir, above all, the safety of people is our first priority. Otherwise, there will be lots of halla gola in a democratic country like us. People's sentiment must be given the top priority. Sir, we are protecting the elephant. That's why, sir, year after year, the elephant number is in increasing trend in the state of Odisha. So, sir, yeah, I remember your point, sir. Definitely, we will not disturb the elephant path, the natural trail of the elephants.
Okay, thank you, Sanjay. I just wanted to bring up a point so that we should
Yes,
think
sir.
ahead
Yes,
of
sir.
the game.
Yes, yes, yes,
Okay.
yes.
Anyway, thanks, Sudhanshu, for a brilliant talk.
Sanjay, what Deva is saying, we need to do a comprehensive assessment when we do a project. That is
yes, that's correct. That's correct. That's correct.
Like one single thought way we cannot go. We need to think the other aspects of that. He's not telling that you are not doing it. He's saying that we need to do it.
Maybe we will have a session on this. You and Sanjay.
What happened? Sir, what happened?
For Sudhanshu and I. Oh, Mahendra, are you saying something?
Yeah. What Sudhanshu was actually telling about forest. He was telling you 10 years back what happened, but now it has changed.
Exactly. Not now. Yeah.
I'm not questioning Sudhanshu. I was questioning.
Could not take seriously on that.
No, Mahendra, I was not questioning Sudhanshu. I was questioning the process itself. So just because there should be thought process involved. Anyway, it's 24 minutes past the hour that we should have stopped. So thank you, Sudhanshu, for a wonderful talk. And I know about your research, so I don't have to talk much. And hopefully you can join future ones and guide our students and other researchers.
I will. I am doing it everywhere. Sanjay will be working sincerely. We'll grow sericia in the forest so that elephant can eat.
Yes, sir. We are ready, sir. We are ready, sir. We will unitedly we will give the best output.
Exactly. Yes. No, because when I presented Mahendra in the CAET, there is a forest specialist, Binayak Babu. His first question was, sir, can elephant can eat sericia or not? Because he thought that if they can get plenty of food, they will not come out to the village and trample people. So, I mean, that kind of thinking we need to have in research. So, we'll be seriously working on how to grow Sericia lespedeza, that fodder in the forest, like wherever the bear area is.
Okay, with that, I want to thank everybody who joined. I want to thank everybody who joined and this and made this a great session for Tea Talk. And we'll see you all in June for another wonderful Tea Talk by Ganesh Padhi. I think he's here. and I look forward to that always. Thank you, Sudhanshu. Okay.
Thank you. Thank you. Thank you, everybody.
Thank you, everybody.
Have a good night.
I would request everybody to join next month as well. Thank you.
Yes. Yes. Thank you. Thank you.